Hello. Welcome to Math 1324. This is Chapter 10, Section 4, Example 1. In this example, I'm going to go ahead and talk about the properties of exponentials. Now, I'm talking about exponential functions, specifically for functions that are in the form of a to the x power. This is the parent function for all exponentials. Now, there are a couple of conditions that a must be greater than 0 and also not equal to 1 for several reasons, not the least of which is to make sure that we have a domain of all real numbers. In other words, we want to be able to use any x value that we get. It has to be greater than 0 because if it was negative, you'd get a whole bunch of holes in the graph. In fact, you get an infinite number of them. It can't be 0 because 0 to the 0 is undefined and it wouldn't be all real numbers. We also don't want to use 1 for the reason that 1 to the x power simplified is just 1, which is just a flat line, and that would look a whole lot different than every other exponential. Now, what that means is that we have two different regions for a. The first region is when a is between 0 and 1. And then we have a is greater than 1. Now, that just means element of. So a is in 0 to 1, a is in 1 to infinity. Notice that I'm excluding the 1 there. Good deal. As for the range will always be 0 to infinity because there are two real different possibilities here. So the first is that a is greater than 1, which will look something like this. This is for a greater than 1. If a is less than 1, it will look something like this. Or in other words, a is between 0 and 1. In other words, if a is a decimal between 0 and 1, or if a is a number greater than 1. So if you notice that this function is actually decreasing from left to right, this function is increasing from left to right. Also, we have a horizontal asymptote. So we have horizontal asymptotes of y equals 0. In other words, the x-axis is a horizontal asymptote. And that actually helps us with the range because this function can go all the way down. It's getting really close to the x-axis, but it's never actually going to touch the x-axis. It's never going to equal 0. Same thing for this one. It's just never going to touch 0 in this direction. So whichever direction, it's just not going to touch 0. Now, notice that this is blowing up towards infinity to the left, and this is going up towards infinity to the right. But either way, it's starting at 0 and going up to infinity for the range. So the domain is all real numbers, and the range is 0 to infinity. In order to graph this, we generally need 3 key points. So 3 key points, and I'm going to kind of just talk about them right now because the 3 key points aren't really all that necessary for your graphing in Pearson because they like to do the horizontal stretch, the vertical stretch, the horizontal shrink, or the horizontal shift, the vertical shift, and the reflections. There's nothing different about this than what you've done in the previous sections. But there are, in fact, 3 key points, and here's how I like to write them. I like to write them, first of all, x and y. -1, 0, 1, with the 1 in the middle for y. As for what goes here and here for the y, it all depends on what a is. Well, in this case, a is just a, right? So just assume a is a. And this negative here means we flip the base. So if a is a can be thought of as a over 1. So we actually use 1 over a there. Now, if you have a fraction like 2/3, flipping it means the bottom goes to top, top goes to bottom, making that 3/2. So just be careful with that. The 1 means you keep the base. And so it's just a there. And there you go. You have 3 key points. -1, 1 over a, 0, 1, 1a. And one more thing. Exponential functions are one-to-one. And that's important. And that's important because if it's one-to-one, it's going to have what we're going to call an inverse. And inverses are logarithms for exponentials. And you'll see more about that in the next section. But for now, in this section, just understand that they are one-to-one, and that's actually going to help us out a little bit later when we're trying to solve equations as well. Alrighty. Well, believe it or not, that's the most important properties of exponential functions. I'll see you in the next video. Have fun.